Welcome to AMS Radio. I'm joined by Rick Bacon, CEO of Aqua Metrology Systems. He'll be talking with us about the role of real-time, continuous, and accurate selenium data for reliable selenium removal treatment processes. So here's what I'd like to know. Why do people care so much about selenium contamination?
Thanks, Carter. So selenium occurs in two principal forms. One is as a mineral, and it's completely harmless, and the other is as a metal. And in very small trace quantities, selenium is actually beneficial to living organisms. However, at levels higher than trace, it's an extremely toxic chemical. It causes birth defects, it bioaccumulates, it's hazardous to human health, fish life, aquatic life, and so really needs to be dealt with.
Well, what are the challenges of monitoring selenium?
So selenium is a very difficult chemical to analyze. The principal way that it's been done until now has been in the laboratory using standard approved EPA methods. The problem is that the application of those methods can actually result, if not done very carefully, in certain components of forms of selenium actually being destroyed, evaporating during the analytical process. And as a result, the amount of the selenium that's detected in the laboratory can be significantly understated. And that problem means that someone who considers that their selenium treatment system is working effectively may actually be contaminating the environment, putting human health, the environment at risk because of that inadequate and analytical process that's occurring based on laboratories. And the other thing, of course, is that take a laboratory sample, it's 2 weeks before you're going to get a result. And in the meantime, considerable damage might have been done to the environment or human health.
Well, based on the severe health consequences, it sounds like we need to get this figured out. What I wonder, though, is have we figured out the treatment process for selenium?
Well, that's another good question. There are a range of treatment systems out there, and I guess the most popular one that is being most extensively used is biotreatment. So essentially, bugs are used to consume the selenium. They die eventually and are removed, and having captured the selenium. The challenge is, though, that you're dealing with living organisms, and there are a bunch of things that can interfere with the effectiveness of those living organisms to capture the selenium, and their failure and those range of interferences. There's several of them. It can range from the quality of the food that the bugs have been given, assuming they've been given it, temperature, and other chemical interferences like nitrates. So you have this living organism that may or may not be working effectively. The level of selenium that they're having to treat is very unpredictable. It's coming from water sources that can have high, very high, or exceedingly high levels of selenium present, and the system's ability to respond to those sudden changes is quite limited. And as I say, the system is vulnerable. It's a living organism, essentially, which means that if it fails to do its job, you're going to get very high levels of selenium in the effluent, putting, as I said, the environment and human health at risk.
Well, it sounds like we have a lot of parameters that are going to affect our ability to safely treat and then actually assure by monitoring that we've effectively treated. Can you provide our listeners with some examples where facilities have benefited from real-time selenium data?
For sure. So the advantage of our online real-time analyzers is, firstly, they capture all of the forms of selenium that are present. So addressing this issue of whether organoselenides not captured by the laboratory process. It's high frequency, so readings every hour ensure that operators are fully aware of what's going on from moment to moment. And so the application of this has been very extensive. We've worked with coal mining companies who, within the coal mining process, coal burning, vast amounts of selenium are generated. They're stored in coal ash ponds, which leak, which have to be treated. So we've been very active in that particular field. We worked alongside oil refineries where selenium is present. We've actually worked a massive project in the Central Valley of California where selenium is part of the runoff from irrigation into canals and has to be captured before that water runs out to the sea and puts the environment there at risk. So we've worked alongside all of the major treatment technology companies. We've integrated with them very closely to provide this real-time data that ensures their systems are actually working as they should.
It's very, very exciting. Well, given the serious health consequences and the variability in detection and monitoring methodologies, it sounds like you've got a really promising application ahead of you here.
I hope so. It enables operators, those responsible for human health, to be much more in control of their systems, to know what's going on. So it's beneficial for those operators, but it's also very beneficial for the broader community as well.
Well, thank you very much, Rick, for talking with us today.
You're very welcome.